Alright, so we're going to go over last year's midterm. There's going to be a few things that obviously are changed. We aren't going to talk about friends at all. I think there was one question on friends. Matches. Okay, well that's a dirty lie. Yes. There is... Oh, is it actually super blurry? You should be able to increase the... what the heck's that called? The quality? Hit the little settings button. Side hand. Otherwise, you could go slightly off of live, like pause it for a couple seconds, and then it should be okay. I'm streaming at 6,500 kilobytes per second, so I would be surprised if it's actually not good quality. Okay, so everyone says. Okay, good, that's good. Alright, what was I saying? Yeah, so friends, obviously I'm not going to cover. I think there's a question on struct. Yeah, so... Oh, of course that's going to find constructs as well. I don't ask specifically about structs in the new midterm, because I think it's kind of ridiculous. They're almost identical to classes, so I didn't think that that was really of any consequence to ask. And this question has changed slightly. So this one, like, this was technically not a UML question in the sense that we didn't ask you to make UML. So this question's been changed. It's very similar on our midterm. I basically just say, like, change some stuff, or like, here's some classes, like, make these and set the inheritance up. And then I give you the UML in case you want to use that to write it from whatever. We'll get to that question later anyways. All right, so let's start with the multiple choice. So last year we had 1 through 29 multiple choice, and it was like randomly worth 40 marks. I have no idea how you even remotely determine how a multiple choice is worth 1 or 2. When I was going through it, I didn't really see any reason why. Like, I don't see why this is a 2-mark question versus like some of the other ones. So I cut that completely. Ours is worth 30. I cut up some of the error questions too. It's still worth 100 marks in total. The midterm is 40 questions, so it's fairly long. You'll have 110 minutes. You'll probably have a little bit longer than that. I'll probably allow you to go right to the 120. Like, that's the end of our class. I don't think there's a class right afterwards. So I'll have to see how Tuesday's startup time is, but you'll get 110 to 120 minutes depending on when we start. It should be more than enough time. There are a lot of questions, so try and make sure you definitely understand everything going in, because it's not just do you understand everything, you need to be able to recall the information quickly, which is, I think, going to be where a lot of people are going to get stuck. Alright, so we'll just go through question by question, and I'm watching the chat. I assume that there's a slight delay. I have it on like low latency, whatever. So it should only be like 5-10 seconds. Hopefully, it's not that long. Actually, can I turn this on here myself? Let's find out. Yeah, it's about 5 seconds. Okay, that's not actually too bad. So 5 seconds after I said something, it pops live for you guys. I'll just have to stop every so often. I'm going to try and watch the chat. If you have any questions, like, or need me to go back over something, they'll go for there. So a lot of these questions should be pretty straightforward, though. Alright, so the following C++ code is best described as an... yes, league is open. I could close that, but... it's best described as an... And then it says, declaration of 2 equal objects, assignment operator call, convert constructor... Oh god, I left this open. Why is my computer lagging? There we go. Convert constructor call or definition. So the answer that he had last year was convert constructor call. So that's C here. It's a little wonky of a question. So I've actually changed this one completely. I would have suspected that, like, I don't like that it's called a convert constructor call. Like, you could also be a copy constructor. You don't really know, like, did I crash it? No, I don't think I crashed it. So for this question, like again, this question I cut out completely. I didn't like it. The answer from last year is a convert constructor call. This, if you type it in like and you had a copy constructor actually made, it would call your copy constructor. So not a very good question, but the answer that he had from last year was convert constructor call. If class, this one I think I left the same. If class X is derived from class Y, then objects from class Y can inherit functions from class X. So the answer for this one is going to be false, because if X is a class that's derived from class Y, then objects from class Y can inherit functions from class X. No, that's not true, because class Y is the parent, so it can't get anything from its children. It goes the other way around. Children get everything from their parents, not parents getting everything from their children. Ox, what is a copy constructor? A copy constructor is... Do I have a thing of code open? That would be really nice. Okay, we're going to open this. Here we go. Actually, do I have Visual Studio open? Would have been easier. Oh, nice. I already had a class put in. Okay, so saying we have some class. What did he call it? Point. Do we know about this class? Not great. Okay, so assume it's got some constructor. Does nothing in this case, and we'll make a copy constructor. So point const. Yeah, fine. Oh, I'm dumb. Is it inaccessible? Oh, I'm completely stupid. Oh. Okay, yeah, so you see that we get this is a copy here. Hopefully that's big enough. Yeah, see, this is where C++ gets like really... So if you explicitly define a copy constructor in this case, then it's going to call the copy constructor. If you didn't, then it may or may not call the copy constructor depending on how things work. Could you do point A, B? Yeah, you can do it that too. So I could say point A, B. And you'll see you get this as a copy. With the operator, you're going to get something like this. So you have point operator equals. And so sometimes you're going to see it typed as this, so like point B. See out this. Oops. This A to B. Actually, we'll do point A, and then we'll say A is equal to B. The way we would explicitly call it. Oh, I'm stupid. Return. Not thus. There we go. So you'll notice you get something funny here. We get this as a copy, then we get this as an assignment, and then we get this as a copy. And the reason for that is because we didn't make a reference inside of our parameters for here, so it actually calls the copy constructor in our parameters of our assignment operator. So if I change this to point reference, then you see we get this is an assignment and this is a copy. So we still get a copy. Now we just get an assignment. So most times with very small objects, it's not a huge deal to remember to put the references. And you'll notice in the notes that in most of the times that I talked about it, we didn't have the reference in here. But a copy constructor or an assignment operator, if you want it to be like really explicit that it's never going to change anything, should look like so. So you want whatever it is, reference, operator equals, const, saying we're not going to change that. Then your object reference, whatever it is, then do whatever you want. Return this. The return this allows you to do things like so. So we can do A equals B equals, oh, I don't like that without the spaces. A equals B equals C. So that actually gives us a situation where like we can push these things together, where otherwise we would have, it would be like, I don't know which of these has to go first because there's no like specific precedence for that. That's obviously a lot different than if we had like the plus operator, which we don't necessarily have to have it return this. It just returns the sum of those two things together. Okay. Where were we? Right. So this one, oh my god. This one is false, because if class X is derived from class Y, then Y is the parent. So therefore, it doesn't get to know about things that X has. It's the opposite direction. So that's just checking like basic inheritance. In C++, arrays that are created using the operator new are created on the heap. This is true. What is the difference between copy constructor and assignment? Basically, like what you saw here. If we don't have, okay, let's comment this quickly. If we don't have this, like, will this even compile? Yes. But you notice that nothing gets called because the assignment operator is implicitly defined. But, so this is what's happening in the assignment operator. So we already had these objects, and then we're saying they're equal to something else. The copy constructor basically says we need to have a temporary version of this object, or a non-temporary version of this object if it's an L value, which is why we have move semantics. So you're going to get a copy constructor call if I did something like this, or if I did something like this. So I'm initializing and declaring on the same line. So this will make a call to the copy constructor. You'll see this is a copy. Assignment is just a way of overloading a portion that says, oh, just make it equal to this. You'll actually find code where the copy constructor calls the assignment operator, or vice versa. Like, that's very common, because if you don't want to have any explicit differences in it, then that's totally okay. Where was I? Oh, yes. So in C++, arrays that are created using the operator new are created on the heap. This is true, at least as far as we know. Technically, we've been giving you a little bit of a white lie, because it's called free store in C++. It should be on the heap, but it's not necessarily on the heap. It's like some compiler craziness. But for all, when copy constructors have pointers, can you give me an example of when copy constructors have pointers? I don't have pointers here. I just have a reference. Like, so this is your default copy constructor. Oh, do you mean like if I had something like int underscore x, and this is technically like an integer pointer? Like, this is when, oh shoot, this is when you want to make your own copy constructor, because otherwise it just literally copies them back and forth. So if we had a situation like underscore x is equal to, I don't know, new int. Let's just say it's equals 7. Not gonna like that. Int y is 7. Sure. This is really hacky, but it's fine. Okay, so we have some. Actually, no, I kind of like the other way better. Underscore x is equal to new int. No way. Why am I blanking on this? There we go. Okay, so we have some new int. So we have, like here we have some new int, and it's stored in a pointer. If we didn't have our own copy constructor, then yeah, I could have dereference x. I'm just going to use it like on the heap, like just so it's really explicit. If we didn't have our own copy constructor, then what's going to happen is we're literally copying this pointer exactly. So the reason why we make our own copy constructors, so we do something like this. We say underscore x is equal to new int. And then we would say something like underscore x, what that's pointing at, is equal to obj dot underscore x. Oh my goodness. What did I mess up? Oh, forgot semicolon. Yeah, so in this case we're saying, now we're making a new place for that memory to be stored, and then we're saying, give us whatever was at the previous pointer. If we didn't have this, then what happens is there's only one integer stored in memory. So if our memory is going to look something like this, like we make some point, and it holds some 7. So our memory is like, memory, bunch of crap that we don't know about, and then there's a 7. So then, when we call the copy constructor, if we don't make our own that has the pointer to it, then it actually points to this 7. So if we change either of those objects underscore x, this 7 gets changed, which means they all change. So the reason we make an explicit copy constructor in this case when it has a pointer is so that instead of using this 7, we say give me a new space, make some new space, so I hold an integer, and then later we say give me whatever this 7 is pointing at and store it here. So then this would be a 7. So now our two objects are going to have two different 7s, and if we change one, it can come 89 or 8 or whatever you want in there. And then this one, you see, stays the same. So this was our original object, so it still has a 7, and our copied object can now have its own 8 and not have to worry about accidentally overwriting the previous object's 7. Okay, so yes, that's true. Question 4. Assuming the function main contains a declaration int k equals 5, the following line of code, int double pointer c equals new int pointer k plus 2. So will this actually run? Will it compile or crash, or will it compile and run normally? So let's what do we have here? First we make an integer k, it's equal to 5. Then we say we have some double integer or some double pointer c, and it is equal to some new integer pointer k plus 2. So we dereference it once, so now we just have some pointer, and then we can store an array at that pointer, which is k plus 2. So that's totally fine. So this k is just going to be 7. This would be the same as saying at 7. And so at c, which is a double integer pointer, we're saying, okay, set that equal to some array of integer pointers of size 7, which is totally fine. So this will compile and run normally. And if we do this, I'll just leave that open. So int k is equal to 5. Int double pointer c is equal to int, oh, hold on, new int. We have k plus 2 or something silly like. Pointer, and I accidentally took out the scope, and I hit the insert button. Good job. There we go. Okay, so let's run this with debugging. So I'm going to put a I didn't put anything in the memory, so that was kind of stupid. Unable to read memory, yeah, there's nothing there. So here we just said, okay, here we have some integer pointer, c. Let's go c at, I don't know, 1 is equal to 7. Doesn't like that. Oh, I'm also doing it while I'm in debugging, which is stupid. It's not technically a double, right, because I didn't explicitly say that I can access that. It's not technically a double, stop. It's not technically a double pointer, or sorry, a double array. It's a double pointer. Double pointers and double arrays are Yes. So if you don't understand, that's actually a good point. If you don't understand what the code is actually doing, and like the options are this, you should probably just like, and you're like, it doesn't look like there's a syntax error, and it doesn't look like it's going to crash with these two lines. You notice that like it crashed when I tried to do something silly afterwards. Then you should just say we'll compile and run normally. That's the easiest way to answer those questions. I believe I took this question out because I thought it was like kind of overly complicated. Okay, let me actually check that so I'm not incorrectly. It's wrong for me. I'll check it on this screen so you guys don't see the midterm. Crap, if I double click this is going to open on the left screen. Okay, good. At least you couldn't see it. Okay, I changed it like ever so slightly, I think. Yeah, so in that situation, like, the only things we're trying to test you here is like so you know that there's nothing wrong with doing this. When did you see Mr. Robot? Tried different screens so hard. Yeah, well, I knew the first page was just the opening thing, so you're not like you're gonna get anything. Okay, so let's go to the next one. See, this one's just randomly worth 2 marks, so I cut out all these randomly 2 marks ones. So if your function main contains C++ code, this. Float, pointer C3, for int I is less than 3, I++, Ci is equal to a new float. More than any third 30 talk ever. Then delete the array at C1. So this code will generate an error during compilation, an illegal memory access at runtime, a memory leak as your program runs, and no problem during compilation time. No problem during compilation or runtime. So the answer to this one is there's no problem during compilation or runtime. However, I very much dislike this question because it's kind of a trick question. He says, if your function main contains the C++ code. So it contains other C++ code as well. Because technically, this is a memory leak. If this was the only thing inside of your code and you ran it in Visual Studio, actually, I can show you. Okay, so here's the situation, and I always forget what the stupid... detect memory leaks, Visual Studio. I think I posted this on Facebook, like how to detect memory leaks. Like, I always forget how to do this, finding memory leaks using the CRT library. There's like 3 things you have to add. I'm just going to copy and paste it. Thank you, Microsoft documentation. Bam. Okay, so you put define CRT debug map alloc std include stdlib.h and include crt debug.h. Don't need to know what that does. Just include some stuff. That's all you really need to know. And then you get this nice little line, which is underscore crt memory dump or underscore crt dump memory leaks. And if we run this, and I'm going to put a break statement here, we output. And so here's the code that he claims isn't going to have a memory leak. No, okay. Missing? Where? 3. Oh my goodness. Good copy and pasting, Jordan. Amazing. Yeah, somebody caught it before I noticed it. Ha! Huh? Okay, so we're running. We're good. Continue. And we finish, and the output is going to be like, oh, hey, look, there's some detected memory leaks here. Yes, because you created all these new floats in this loop, and you only deleted the one index of it. So it's kind of a silly question. Know that if I ask you a question like this, I'm going to make it if your function main contains only this C++ code. So it's really explicit that, hey, it's only the C++ code. And then you know that, okay, that's actually a memory leak because we created 3 sets of float arrays, not integer arrays, and we only deleted the one of them. Okay, next one. Here's another random 2-mark question, even though it's only true and false. So assume declaration int a pointer b equals new int 10. In a C++ program, the statement a equals b3 is equivalent to a equals pointer b plus 3. So this is true. This is also equal to if I do something like 3 at b. Those are also equivalent as well. How would you delete a double pointer? You have to delete. Okay, so if you're talking about making a double pointer and then you've actually created stuff, we did it in labs 4.5. So you would actually have to loop through and delete all of the arrays that are at that, and then delete the upper one. Do I have lab 4.5 around here somewhere? Labs 4.5. That's the right one. Is this the older one where I didn't call all my deletes in it? Yeah, I bet you it is. Or maybe I had you guys call the deletes. Okay, so for each of these, you would actually have to delete the array that's being pointed back. So for notice we make a new array here. So that array has to be deleted, and this array has to be deleted. So you'd have to call delete array basically inside of a for loop. I'm sure there's some C++ 11 way to do it like all in one line now, but I don't know it off the top of my head. All right, so this one, assume we had some integer a and some pointer b, and it's equal to some new int on the heap. In C++ and a is equal to b3. So remember that the subscript operator is equal to the pointer operator, and then you pass the pointer itself and some offset. The offset is always going to be equal to the size of your type, which is really nice. And if you get used to coding in C, you'll have to get used to calling size of all the time, but C++ is sometimes really nice to you and gives it to you. What does a memory leak even mean? So a memory leak basically means that you said to the computer that, hey, I need this memory, I'll give it back to you later. Then you place memory there, but you never told the computer later that it's allowed to use that memory. So you end up with situations where, like, if you have a memory leak in a program that runs for a long period of time, then it'll just consistently eat up more and more memory. Like, you'll watch this program just eat up RAM, like, for long periods of time. It may be very slow in stuff that we're doing, because, like, you may just forget to make an integer, but assume we had some object in memory that's like, I don't know, 200 megabytes. So we had 200 megabytes worth of some object in memory, and we forgot to tell the computer to actually free this memory or to delete it. Then that 200 megabytes is just sitting there, and later we're like not using this 200 megabytes. And later we make a new object, and we use this object, and then we forget to delete it. So now there's 400 megabytes worth of memory that the computer can't access. Like, you've told it explicitly your program still needs this memory. And then later that happens again. Now there's 600 megabytes that aren't being freed, 800 megabytes, etc., etc. So this program could run for a very long time and just like constantly eat up memory. What you need to do is, I'm done with this memory, and then either call free, which is the C way of doing it, or delete, which is what you do in C++, and that will actually give the memory back to the computer, and you're just like, oh hey, you can use this for something else now. Hopefully that cleared that up. Yeah, so these two are equivalent. I could have also said A is equal to, oh, I just saved that, whoops. A is equal to 3B here, like where you pass it this way. This is also equivalent. This is basically the same as saying 3 plus B. Question 7. The size of a vector variable is fixed throughout its lifetime. This is false. Hopefully that one's pretty straightforward. A copy constructor of a C++ class is automatically called when an object is initialized from an object of the same class, an object is passed by value to a function, an object is returned using a return statement from a function, and all of the above. So this is all of the above, because an object is initialized from an object of the same class. So that was when we do something like point A, B. This we'll call the copy constructor. This one's equal to is passed by the value of a function. So we remember with our assignment operator, when we return just point, not the point reference, it called our copy constructor as well. Wait, is that passed by value to a function? Okay, so that's when we actually had our our assignment operator not have this in front of it for the parameter section. I'm just going to write the whole operator here. So, okay, here's the proper operator header. So if we take this away, this is what it's saying. So this point here, we'll call this A, is actually going to call the copy constructor because we're saying, oh, hey, we're going to pass this object by value. And so therefore, to do that, we have to make a copy of that thing. So if you didn't want to call the copy constructor here, we would make this a point reference. And this one is the same as saying this one up here. So if we have this reference, then the copy constructor is not called. If we don't have that reference, then the copy constructor is called. So an object is returned using a return statement from a function. The object itself is being returned here. It doesn't say a reference of the object is being returned, so therefore it must be calling our copy constructor. So the answer to this would be all of the above. So let point be, let point be a class. Sorry, what was I saying? Let point be a class and assume declaration point pointer C3. Holy man, this question is not very well written. Okay. Let point be a class and assume declaration point pointer C3. Okay, fine. So we're making some point pointer. Why would you use point? Now I have to say point pointer. So we're making some point pointer C3. Okay, so it's a double pointer. To delete from the heap a point object allocated in code C1, one can use the following statement. Oh, I see. Right, so he's just basically saying we have some points array here, and it's a point pointer here, and we're like, hey, we make some new point in this particular situation. If we want to delete this point, how do we do that? Well, this one obviously is incorrect, because this saying, did I skip 9? Oh, whoops, I did skip 9. Okay, I'm going to go back to 9. Because this one is saying delete C plus 1. So this is actually an expression, C plus 1. So it's just going to call point C, look for its plus operator, and try and add 1 to it. And then that's just going to make no sense and probably cause a compilation error. This one explicitly says, oh, these two things being called together is with this dereference operator. Oh, it means that take this guy, add 1 to the offset, and then delete it. So that would work totally fine. So this is equivalent to saying delete C at 1. Because remember, this is equivalent to this, and that question basically gives its answer away if you had this question correct. Question 9. Let point be a class. To delete from the heap a point object that was dynamically allocated in the line of code, point B equals new point, blah, blah, blah. Once you use a statement, delete B. Yes, so you would use this statement here, delete B. This one says delete the reference B. That's not what you want to do. You actually want to delete the object itself. B equals null. That doesn't do anything. That object is still in memory. You've set your variable to null, but you haven't actually called delete on it. B? What does it point to? Call the... Okay. You should never, ever call the destructor explicitly. So by definition of that, this is clearly wrong. You should always call delete for those specific things. The destructor is called for you when something is deleted. You should never be calling your destructor explicitly. I'm not going to go over this question because it's not on the midterm anymore. This is in our polymorphism lecture. A pure virtual function is also called an abstract function. That's true. They're the same thing. Just C++ likes to have 8 bajillion names for different things. I don't know why. An entire class can be defined in the friend of another class. This is true, though I'm not going to ask you about it because friends should never be used. An abstract data type is a collection of data. This is false. An abstract data type is a blueprint for how you should make a collection of data. It's not a collection of data itself. So an abstract data type may be something like a car, or sorry, a vehicle, and then you would implement car as the specific. Friends should never be, yes, friends, here, I'll give you a link to it. Should we ever use friends? C++. When should you use friends? Yeah, so I was hoping for some like really cheeky. Usually there's like somebody like decides to get angry at people using friends and like really cheekily write something about it. There's the problem with friends is that there's no there's no like use case where using friends actually makes things easier. In most cases, what you end up happening is just completely breaking encapsulation, which is like really, really bad coding practice. It's sort of similar to the mantra of like goto is bad. So it's not that goto is necessarily bad, or it's not that friend, for example, is necessarily bad in itself. It's that the number of times that you can come for a use case of using goto or friends, vice versa, properly is so incredibly small, you should just not use them at all. Yeah, an ADT is just an abstract idea. So a linked list, for example, is something that hasn't been created. We just have a blueprint, and we're saying these things have to be implemented before you can make one of these. And then you leave the implementation details up to somebody else to do it. Or you make it yourself because, you know, it's 1037. Consider two function definitions, swap1 and swap2. So this one uses two references. This is an integer reference A. This is an integer reference B. Int t equals A equals B equals T. Fine. Void swap2. Integer pointer A, integer pointer B. Integer t is equal to whatever A is pointing at. Whatever A is pointing at is equal to whatever B is pointing at. Whatever B is pointing at is equal to T. So are these equivalent? Yes. Oh, Gotham already answered that. Perfect. Glad that people are answering stuff inside the chat. So yes, these two things are equivalent. There's no difference. These will both run, and these will both swap the integers that are at A and B. This one will not, the first one here, void swap1, will not compile in C. The reference thing as a parameter actually got added to C++. It's one of the things I like about C++. This is the more C-style way that you would have done it, was with pointers. If you think you guys have to use a lot of pointers in C++, if you code in pure C, it's basically all pointers. It becomes a lot grosser if you're not good at pointer arithmetic. But these two things are completely equivalent in C++, and both will run and swap the integers that are at A and B. Okay, in C++, the operator delete can free memory previously allocated to a local variable objects declared inside functions. I absolutely loathe this question because it says delete can free memory previously allocated to local variables and objects. Like, previously allocated suggests that like there was some other allocation apart from when you allocated it the first time. So whoever wrote this question didn't really go through that. Like, if I was writing this question, I'd probably say can free memory allocated. This previously just makes it really confusing. Let's just assume that's the question. In C++, operator delete can free memory allocated to local variables objects declared inside functions. This is this is false because of the fact that he says declared inside functions. So if we declare something that's inside a function, oh, that's why he had previously. Oh my god, this question is really wordy. If we declared something previously inside of a function, then when we return from that function, we no longer, unless we've returned an access to that, so we like return the thing that we created. So like, let's say we say a int. Oh my gosh, Jordan. Int a equal to new int 1. Fine. And then we do something like return something that isn't A. If we do that, then we have no way of deleting this anymore. Yeah, exactly. Because we've no way of deleting it anymore because we no longer have a way of accessing what's inside of that function. If we returned A, then later we could say delete A, or whatever we returned A in, and that would be okay. It's actually probably not. Like a lot of these questions, like when you get something like this, you're just like in C++ deleted previously. A lot of the questions that were like oddly complicated, I've taken out. So if this one seems a little harder than you expect it to be, ours is easier. At least I think it's easier. It's easier for what I've taught and what you guys should understand. Vectors degenerate to pointers like array. Nope, vectors are container classes, so therefore they don't degenerate to pointers like arrays. Assume that a member function of C++ class is declared as follows: int set value const inst reference of value. Then the following is true. The function is prevented from modifying the parameter value. That's true. The function is prevented from modifying the object of the class. That's not true. Both A and B, none of the above. Okay, so then the answer to this one is going to be A. The function is prevented from modifying the parameter value. How do we know this? Well, because we just have const. Const says that we actually cannot change whatever happens after here. Does degenerate mean anything? I posted something on the Facebook before. The two words you're going to see a lot are degenerate and decay. So it's going to be degenerates to a pointer or decays to a pointer. And so when something decays to a pointer or degenerates to a pointer, it just means that when we make an array in memory, where is it? Because they had a nice little picture and it was a lot better than me trying to explain it in words. Oh my gosh, our Facebook group moves way too fast. Seriously? I can't even find it. C lang r array pointers equivalent. This is not the ones I want. They had this nice little picture of it. Hold on, I know I sent it to my buddy because he's an idiot and didn't know that. Let's hope that we didn't talk that often. Here we go. Okay. Oh, did I just show my IP torrents thing? Oh, it is not down. Private stuff is for the win. What was I saying? Okay, so is this the good one? What does it mean the equivalence pay? No, I actually want this one. This one. This is point 2. Ah, okay. So this is basically what the same. When we say that we make some character array A, in this case, and we set it to hello, then what actually happens is we initialize some data structure that's represented in memory like this. So A represents this whole section of memory, hello. When we pass it to a function, what happens is we say, oh, well, we don't have a way to know that this is still an array anymore, so instead we're going to make a pointer and point it to some section. So these two things are, this one's an array here, and this one's a pointer. Even though the subscript operators of both can be used the same, So when we see the expression A3 or P3, it doesn't do the exact same thing. When we say A3, it just says go to A, which is here, and move 3 past it and fetch the character there. So we'd actually go to the array A and move till we get this L. With this one, we would say go to P, whatever P is pointing at, move that the size of what it's pointing at 3 forward. So it would go 1, 2, 3, and it would point at 1, 2, 3. It would point at the third location that you're aiming for. So it's going to be this one here. So 0, 1, 2, 3. Because it's already pointing at the W, then it's 1, 2, 3 forward. So they're not the exact same thing. Const XXX and XXX const. Oh, that was actually explained in the first set of lecture slides, actually. I'll pull up the lecture slide. First set of lecture slides, second set of lecture slides. Const parameter. Not this one. Winners? Oh my god, 28? It's gotta be in here. Okay, this is saying that this whole function is constant versus just a single thing. So this is saying this pointer is constant. I know we have an example of it here. This is saying the integer is constant and it's a constant pointer. Where the heck is the... So I just go through the whole thing. I went through the whole thing. RIP! Node 5. Okay, thank you. Somebody else is finding it. Wait, Node 5? Like more classes extended? Oh, and constant member functions. Yeah, okay, perfect. Okay, this is the portion that you're looking for. I'm going to say, I'm actually not sure how to pronounce your name, but it looks like Mario, so I'm going to say Mario. Alright, this is what you're looking for here. So it's in number 5. So this is like, when const appears in the parameter list, then the function is prevented from modifying the parameter. So it can't modify this. When const follows the parameter list, so like this, the function is prevented from modifying the object. So remember, the object itself, you can say that we want this getter, in this case, to be constant. So that means that we're not going to change anything inside of our object, which is correct. So if we try and change anything inside of our object, inside of our getter, then it'll say, hey, you can't do that because you told me this is constant. Where was I? This one? This one. 2. Okay, I already said that part. Okay. Did I go to this one? Okay, so suppose that your C++ program has the declarations integer pointer p, integer pointer q is equal to new int. Then this statement p is equal to new int and be equivalently replaced with p is equal to q. No, that is not true. P equals new int says that we're making some new space on the heap to hold an integer. P equals q is saying whatever this integer was pointing to on the heap, this p is now pointing to that as well. So this is false. These are not the same thing. One is going to create 2 integers, and one is going to create 1 integer and 2 pointers pointing at it. The C++ statement string s hello invokes the following type of function. A friend function? No. A copy constructor? No. A convert constructor? Yes. And none of the above. Well, we said yes to the convert constructor. So the reason this is a convert constructor is because this is actually a character array. It's not a string. So strings are added in C++. I'm hoping you guys were taught strings decently well in 1036. You should have. And basically what this is saying is that hello is a character array. So when we pass it to the string situation here, what it'll actually do is return a string representation of the character array object. So that's a convert constructor. The constructors for C++ classes are normally designed as public entities? I would hope so, because otherwise I have no idea how you would bother calling them. So this is definitely true. Constructors should always be public because you have to call them from within main methods or within other functions to actually create the objects themselves. A static member function of a class can be called before creating any objects of the class. This is true. A static member function of a class means that it's a member function of the class, not of the objects. You don't have to create any... I think I made one of the llamas. I don't have to create any of a particular class to use a static member function, because there's only one version of that. We're saying it exists within class. It doesn't exist within an object itself. If you guys came from Java, this would be like super apparent, because everything in Java has to be a class. So things like functions don't exist in Java. They're only methods because they're invoked on something that's a class. So a static member function of a class can be called before creating objects is true because we actually create it in the class itself and we're calling the class with the scope operator. We're not calling an object. A static member variable of a class must be declared in the class. This is true. Must be defined outside the class. This is also true. Both A and B. So that must be true. And then none of the above. So this is, oops, I just tell us of this. This is both A and B. It has to be declared inside of the class so that we can access it. We define it outside of the class so that we don't accidentally include it multiple times inside of a header. And then we say, so then the answer to this must be both A and B because both A and B are true. The this pointer in the member function of a C++ class. What is a static member function in C++? We talked about static member functions in 5, I think. It just basically means that there's only one. So it doesn't get called on the object itself, it gets called on the class. So there's a situation like, let's say we have, I think one of the reasons, or one of the options in the notes is like we have a person, and each time we make a person, we want to increase some counter. So we make a unique person ID, and we call it static. And so that only exists for all the classes. And then each time we call the person constructor, we grab the unique person ID and we plus it once, and then the unique person ID is stored as the person's specific ID. Oh, can we code up an example? Sure. There's one in the notes. Let's grab that one. Actually, I'll just make it on this guy. So your memory leak, get rid of this. What the heck did I just do? Okay, class, something. Good old something. And we'll say it's got some public something. I don't know, underscore x is equal to 7. Int underscore x. Say some static thing here. Static. What do we want to make? Int. I don't know, let's call it y. So now we have some static int y, right? So this exists in the class something, not in the objects of something. This guy is non-static, so there's a different version of, I'll get to that in a second. So this is there's a different version of x for every single time we call something. So if I call something here, like something s, b, d, oh, that's supposed to be a comma, so s, okay, here's a bunch of something calls. So that means, and one of them stat apparently. So that means that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I just changed that. 11. So there's 11 objects here. Each one of these objects has its own version of x. Every single one of them. Let's actually take this guy and make it this. So this is this is really bad, but this is going to make it really quickly. Shouldn't you place the static member variable to private? You can. It doesn't really matter. let's say I go s dot underscore x, oops, is equal to 9. Now I say cout, I'm using Nasus, right? Okay, cout s dot underscore x. What's another one? C dot underscore x. Okay, so now I'm going to cout those two x's. Redefinition of D. Did I actually have two things called D? That's hilarious. That was unlucky. Okay, so you notice that we printed out 97. Because S is now 9, and C is now 7. Or sorry, C's X is still a 7, and S's X is a 9. So now we have some integer X that's, or sorry, some static integer Y that we declared inside of class something. So then later we say something Y, I don't know, we'll equal it to 9. That's not a very good example. So that, oh my goodness, how do I want to do this? No, I don't want to do that either. I should have actually made like a decent example of this, not just called it something. What was the example we used in the notes? Okay, fine. We're going to stick with calling it something. Something. It just doesn't make it obvious why we would actually do this. Okay, so we make some int that we're saying something. I don't know, what do we call it? Y? Call it Y. Is equal to 7 in this case. So now for every version of something that we create, we actually have only one version of Y. So this actually exists regardless of whether or not we make a something. So if we say cout something.y, sorry, this has to be the, there we go. The scope resolution operator, not the dot operator. You'll see that this actually prints out a 7. So we were able to call that static member. Do you need int in front of something? Yeah, I did. I needed int in front of something here, because otherwise I'm saying, see, this will say the declaration has no storage class or type specifier. So it actually doesn't know what to do with this. It's like, what am I doing with this number? Like, I can't set anything to 7. So you say it's an integer. Which is kind of weird because you technically declared it inside of here, but so I mean this is actually a static member. It's just a variable. I could have put it up here like somebody had mentioned before. So static int y. But now you're seeing that, oh hey, this is inaccessible. So we actually want it to be in a situation where if we want to ever call it in something other than ourselves, then it has to be public. No, you can't, because it's inside of the class. So you can't access Y without also going through something, because we declared it inside of the class. So it only exists within the class of something. So it's a class variable. It's not an object variable. So now if I say, okay, here I made a bunch of somethings, right? And here I printed out these two guys. This was 9 and 7. So then if I later say I would cout, I'm just going to copy this. So now I'm seeing out something Y again. It's still going to be 7. So 7, 97, 7. So it's still 7. So I made all these something objects, and then we set to 7. Now here's where it's going to get tricky. Okay. This is kind of abusive notation, assuming C++ allows me to do this. Okay, so I'm going to take one of these guys. It's sad. We're going to say hit as Y. and we're going to set it equal to 9. Okay, so now I'm accessing the static variable y inside of sad. Okay. We'll see what this prints out. So the static variable 7, right? That's our integer y. Then the 97 was our x's that we printed out with s and c. And now you notice that I said sad.y is equal to 9. Something's y is now 9. Yep, I can. That's what I did here. I just changed it with this sad.y. So now if I do something like, okay, well, something's y is that. So does that mean that everyone's y is that? Well, yes, it does. Because if I say, like, let's say c at yh dot y, you'll notice that it's 9 as well. Because there's only one version of y that exists for the class of something. So no matter how many other somethings I make, so now if I make another something, like say something, I don't know, some other thing, and I say cout some other thing, oh hey, that's not what I want, some other, oh my, thank you. So we're saying there's a y inside of some other thing inside of the class something. Like, get me what that is. I should close half of these. And you say that one's also 9. So even though we created this something after all these happened, because when we changed it with sad.y, we're actually changing the static variable inside of that class. So now it's going to be 9 for every something that exists before and after that. That makes it static. It exists inside of the class. There's only one place in memory that that integer is stored. Whereas in x, there is a different version of x that is stored for every single one of these objects. This is equivalent to having an actual static, let's say I have static int y, and it does something. Expect the type expression. Yeah, so if we want to actually, let's come up with a good member actually. Static function. What's a good name for this? Static. Yeah, okay. We'll go static int. I don't know. What are we going to call this? Some static function. Let's go with that. So now we're making some static function inside of our class something. And we're saying, okay, well, that has to do something. So it has a parameter list. And in this case, it's going to be equal to something. So no matter which one of ours is going to call this, let's return. Right. So if I went like this and I said this is just y. And first, I can't access it like this anymore. I can't access it with the scope resolution. Yes. The child class would also have access to the exact same static y. Yep. So you notice when I take it, it's no longer static. I can't access it with the class scope resolution anymore, and this becomes like invalid. When it is static, I can. So this static int some static function is basically saying that like it's the same as having a static variable, where that function itself only exists within the something class, not a separate version of that function for every single one of the objects that's created. Where'd the midterm go? Ah. Okay. You get distracted again with that. Where was I? This pointer in the member function of a C++ class points to the object calling the function. This is true. So this pointer is just saying, whoever's calling this object, we have this. This kind of got added in later. If you come from a Java background, it's like people use this all over the place. It just basically means whoever's calling it, like, we want to have an explicit way of calling this. Now remember, how I do it is, instead of having use this all the time, I just underscore all of my member variables. So like I always say like underscore x, so then I can make like a parameter like some function int x, and then inside of my function I don't have to say this pointer to x. I can just say underscore x, and as long as I only use underscores for member variables of my objects or of my inside of my class, then I never have to worry about using the this keyword. But the this keyword does point, or the this pointer actually points to whoever called that function. An abstract class is a class with at least one abstract member function. This wouldn't be asked because I think we didn't really cover that until polymorphism, so I believe I just cut that out. This is true, by the way. So any abstract class has to have at least one abstract member function. Okay, here's some basic inheritance stuff. Assume class B is derived from class A in a public inheritance model, as in class B, public A. So the non-derived member functions of class B can access public member variables from class A. So B is the child. It's derived from A. And it's public inheritance. So we know that whatever the access specifier was before inside of A, B also has those access specifiers on all of its stuff. So can we access public memory variables from the class A? Of course we can, because they're public. So even if we weren't inheriting from A, we can still access them because they're public anyways. So this is true. Okay, next page. Assume B is, oh, what the heck did I just do? Assume B is derived from class A with no access specifier, as in class B A. The non-derived member functions of class B can access public member variables from class A. This is also true. By default, what this is going to be is private. So remember, everything by default in classes, if we don't specify an access specifier, is actually private. So in this case, we're saying private A, or we can just cancel that out completely and say A. So something is privately inheriting. If it was private in A, then we wouldn't be able to access it. If it was protected in A, then it's now private in B. But if it was public in A, then it's now it should still be public in B. Non-derived? When did I say the non-derived? Oh, right here. The non-derived member functions of class B. Oh, it just means that member functions that exist inside of class B that didn't originally exist inside of A. So here, where's an example? Let's get rid of our crazy static thing here. Okay, so class A int underscore x, sure, and public. Whoop, this is not Java. A underscore x is equal to 7. And member access. Yeah, base access for classes is always private. Just remember that. So if I didn't say anything here, this is private, right? So like the next line I would have to do is say public for my constructor. Class B inherits from A. Okay, so here's our class B. So everything from A that was public, we also get in B. But not private, yes. So we can't access this X. But if it was public in here, so let's say we have some other thing called int underscore y, then B would be able to access this. B, whoops. So we say like underscore y is equal to 7. And you'll notice that no errors, that would be totally fine. But if I said something like underscore x is equal to 9, It's going to be like, you can't access that. That is completely inaccessible because it's private in here. So even though we're inheriting from A said explicitly that it wants this to be private. We had private number 23. Number 25. I don't understand the question. Oh, I see. Right, so in this case, what was the difference in this question? Or was I? I keep getting, like, confused here. Yeah, because there's a public member variable anyway, so it doesn't matter. Like, we can access it regardless. So remember, like, here's a public one. We can still access it here. Because even though this is private, we can still access it because it was public up here. Now let's say we had something like this. Whoops. Okay, so now we're saying that's protected. So can we access this? Yes, we can. But let's say we had a third one, class, I don't know, C, that inherits from, even if it's public, we'll say it inherits from B. And we'll say public, need to make some constructor, so C constructor, blah, blah, blah. And we say underscore x is equal to 10. Ah. You notice that, oh, hey, you can't do that. It's inaccessible. Because protected from class A, and then we said private inheritance from A. So B knows about A, but it makes its access specifier of X private. So when we have another class that inherits only from B and not from A, then its underscore X is actually private. It can't access this. Now you can do crazy things like see, now you get, oh, well, now I don't know which one this is because it's ambiguous. That's why multiple inheritance is really bad. But if this was A, now we can access it again. Because we're saying, okay, like, I'm inheriting from this guy, and he had it protected, and I'm a child, so I'm in the protected, like, section of things that are, sorry, protected means that you and your children can access it, and since I'm a child of A, then I can access this as well. No. If we had class B, public A, could we access the private variables of A? No, because they're private. Private means no one can access it except you. Doesn't matter how much your child screams and wants it, only you can access it. Public means everyone can access it. Protected means, I almost never ask protected because there's like very few use cases on it. I think I'll ask a couple things about private versus public. Those are the very common ones. Remember, private means only you have access to it. Public means everyone has access to it. Protected means only you and your children have access to it. I had that. Okay, 26. Okay, 27. This one is going to be a little tricky. So questions 27 through 29 refer to the following sequence of statements in a C++ program. Double pointer array, j equals 3, k equals 5, pointer p. Array equals new int, and it's an integer pointer, and we're using the subscript 404. P is equal to the reference of k. So whatever k is referencing, p is now equal to that. Here we have the pointer, and we're now saying it's equal to whatever j is referencing. Here we have the array at j is equal to p. Pointer p is equal to 2. Then we're going to see out whatever array at 0 is pointing to, and then k, and then end line, and then we're going to set p is equal to whatever array is pointing at its 0 index, and then we're going to double dereference array and say that's equal to 6, and then we're going to say see out what j is, what k is, and what p points to, and that's 2. Okay, so let's look at this. First question is AIR. That's cheeky. I don't remember how I wrote it on mine. Assume I'll actually make a note of that when we talk about the midterm. Assume when I put a space like this, it's just for readability's sake, I suppose. I can't remember how I changed this question, I think, ever so slightly on my midterm. I can't remember if I left it like this or not. Okay, the values printed by the line labeled 1 are as follows. So what is the line labeled 1 as? Oh, so first we're printing out the array at 0, then we're printing out k. So what is the array at 0 going to be pointing at? Okay, well, look, what did we do to our array? Well, we set it equal to a new integer of this. Then we set it equal to j. Well, j is 3. So whatever this is pointing at, we're saying the reference of j. Well, the reference of j is going to be equal to 3. So this is going to print out a 3. So we don't consider this, we don't consider this, we're only looking at these last two. So what is k? K is equal to 5. Okay, do we ever change k? Well, p is equal to the reference of k, okay. Then we say the pointer of p is now equal to 2. So there, we actually said whatever k was pointing to, that memory location was 5. But we stored that memory location in p, and p is a pointer. Then later we said, whatever you're pointing to p, changing it to 2, which means that k is now a 2. It's no longer a 5. So then the answer would be 3, 2. The values printed by the line labeled 2 are, okay, so let's see, what did we have changes here? So p is equal to array at 0. So now, remember, p is a pointer, so it's now pointing to whatever array at 0 is pointing to. Double dereference array is equal to 6. Okay, so whatever its first one it's pointing to is now going to be a 6. And what are we printing out? We're printing out j, k, and p. So what is j? So j was 3 up here. Did we change anything with this? Okay, well, array here is now equal to the reference of j. So the first portion of this array was now equal to whatever j was pointing at. So it was a 3. But then down here we said, we doubled the reference array and we said, oh, you're equal to 6. So this is actually going to change what j was pointing at. So this will be a 6. So we're going to print out a 6 here. So we know that it can't be b and it can't be c. It could be still d, but we know it's either going to be a or d. So the next one is k. So do we change anything with k? Well, p originally was pointing to what k was pointing to. But now we're saying p is now pointing to this other place. So k should still be the same thing. So it should still be 2. So then we know that it's 2. So now we don't even have to look at the other one because this is 6, 5, 2, and this is 6, 2. So we know that this must be the correct answer. We also know that this is a 6 because we're dereferencing whatever p was at. P is pointing to the start of array at the subscript of 0, which is just basically where that array is pointing at itself, which we set equal to 6. So it's going to be 6, 2, 6. Okay. For each of the following pieces of program. Okay, so I've cut, there's 3 of these I think that was on the, yeah, there's 3 of these on last year's midterm. I actually cut it down to only 2, because I don't really like these questions that much. So for each of the following pieces of program, indicate if there's an error, syntax, compile time, runtime. You just have to indicate whether there's an error. You don't have to say which type of error it is. If there's an error, if there's no errors, say no error. If there is an error, or more than one error, there might be an error, there might not be an error, there could be more than one error. If there's no error, just say there's no errors. If there are errors, you have to say what the error is, answer why it occurs, and fix it with as little addition or change to the existing code as possible. So if there is an error, and you just say there's an error, you won't get any credit unless you actually identify what the error is and corrects it. This one's really key. You can assume that all required header files are included. So let's look at this first one. We have some parent class, has some integer id 1 is equal to 1, parent class int x, id equal to x, class child class public parent class int id 2, parent class pointer b is equal to new child class pointer c is equal to new child class. So where is our errors first and foremost? Okay, well, first of all, this one can't be initialized right here. Why? Because you can't initialize a variable like this inside of a class definition. Second, we say id is equal to x. that doesn't make any sense because this is ID 1. And on top of this, this is private by default. So the two errors that you're basically looking for is that this shouldn't be initialized and its name is wrong. Either you can say this name is wrong or this name is wrong. And that there should be public in front of this. Otherwise, we have no way of actually accessing this parent class constructor, because it would have been, oops, I didn't mean to underline it, because it would be by default private, and no matter what type of inheritance you have, if it's private, only you can access it, which means the child wouldn't be able to access it. So the answer to this one would be, like, first error, ID 1 cannot be initialized in definition, and second error, the constructor for parent class needs to be public. Yeah, no member variables should be initialized in the class definition. That's usually a huge no-no. You initialize them inside of the constructors. That's what the constructor is there for. Okay, question 31. We have parent class, we have an int ID 1, parent class int x, parent class int xy. Okay, so two constructors. First and foremost, we should already realize that there's an error here. It's the exact same error as before. I mean, I think I actually changed that in mine. That I did free it afterwards. But I would be totally okay with that being an error as well. Like, if this is a 5-mark question, and you found 2 errors in each of them, then like you would get the full marks for that. Parent class ID 1. You see, you did it here too. Actually, you're gonna find later that there's a whole bunch of questions where it says assume there are no errors, and there's like a ton of memory leaks. I think I caught and fixed them all for the questions that I reused myself. There shouldn't be any left. I went over it 7 or 8 times, I think. So we should be okay. But yeah, like, technically this is an issue because, like, we're saying new child class and then we return 0. So, like, this memory is never, like, we're never actually deleting this memory. So there should be, like, a delete B, delete C somewhere in here. But assume that it's actually in there. What was I saying? Right, so the 3 we're looking for is public should be here. So again, constructors should be public. So that's going to be your first one. What else do we need? Okay, well, the class constructor is actually using or child class constructor is actually using the parent class default constructor. So there's no default constructor in here. So either you have to set this to a default value so that you're actually overloading the default constructor, or you need to have some default constructor for parent class. So needs extra constructor, constructor, not constructor. What's the third error? Oh yeah, well obviously this one, the same error again. Constructors need to be public, so you'd be like, constructors need to be public. Boom, there's your 3 errors. I mean, obviously there's the errors with the memory allocation. And if you pointed that out, whoa, if you pointed that out, that would have been fine too. What the heck did I just do? Breaking everything. Ah. Okay, 32. Okay, here's one. Now we're using shape instead of child and parents. So we have, what the heck? We have some class, no, stop. Boom. We have some class shape, double side, shape double. Okay, so obviously, first and foremost, public. So that's going to be an error. So, constructor should be public. Virtual double area, this is technically for polymorphism, so this type of question wouldn't be asked, but that's okay. So then we were going to look down to square, and we know that square is inheriting from shape. So it sets up double side. Then it says public square double T shape double T. Okay, so this is, yeah, you could have done that too. You could have written parent class index as long as it compiles, right? That's why I don't like error questions, because like kind of set it up so that it's supposed to be this way, and then they're a pain to mark because there's like 8 bajillion possible answers that you have to accept, which is why there's only 2 of them, and I made them a little bit more tight. So this won't compile because of this. Double T, double T. Whoopsie. So this actually has to be just plain old T. You pass T to shape, not double T, because it's already declared here. So the parameter list for shape should not have the variable type double. And there should be a third one somewhere here. Let's see. Oh, this is silly. You can't do this. You actually have to, so s dot area, so we have some pointer here. Like this would actually have to be s pointing to area, or the pointer notation of s dot area. So that would be the third error there, because s is a shape pointer, not necessarily a shape itself. Again, I don't know why he made everything new. So this one wouldn't be asked because it's using virtual, and I didn't want to ask anything about polymorphism. But if you're curious what the answer is, that's what the answer is for that one. Okay, part 3. These ones, I actually like output questions. I think they're a good way to test stuff. Okay, so in each of the following questions, write the output of the program in the output box, and write why you think that that's true. So you just have to write the output, and then write a brief, description of why you think that that's true. So we have some parent class, I'm the parent. Some child class calls the parent class default constructor, I'm the child. We have some parent class, new parent class, and we have some child class, new child class. So what does this actually output? Okay, so parent class is going to call the parent class constructor. So I am the parent. That's definitely going to be the output to start with. The second one is going to be child class. C is equal to new child class. So what does the child class constructor do? The child class constructor calls the parent class constructor first. This means I am the parent is going to be output. Then it's going to print out I am the child. So these are going to be the 3 output statements that we have, because there's nothing else after here. We just have return 0. And for explanation, you could just be like, the child class constructor calls the parent class constructor. Thus, the output is, thus the output of I am the parent happens twice. Once from parent, once from child. And that's all you would have to say for this one. 34, we have something similar. We have a parent class, public void print, parent, child class, inherits from parent class, public void print, child. We make a new parent class, we make a new child class. We call A print, and we call B print. So if we call A print, it's going to print parent, because we called it on the parent. If we call B print, because it's a child, it's going to print child, because we called it on the child. So that would be your output. And for an explanation, we say, okay, well, A is a parent, B is a child. Should say pointer, but if you forgot to say that they're pointers, that's totally okay. Therefore, when we call the print function on each of these objects, we get the specific version in their definitions. And that would be the answer to this one. It doesn't have to be this wordy. You can just be like, it's going to call the... Yeah, we'll ask for explanations, but they don't need to be, like, they just have to be very quick, simple, like, this is the pointer, or sorry, when you call something like this, it's calling print on A, it's calling print on B. A is a parent, B is a child, therefore it calls the print of parent and the print of child for those two particular calls here. Okay, so this is another one that was taken off completely because this has got virtual in it. I can go through this one pretty quickly. So parent class, virtual void print. Child class gets from parent class. Public void print, it's a child. Okay, so we make A is equal to some child class, but it's stored in a parent class pointer. We make B, which is parent class pointer, and then we static cast it to the parent class. I'm not sure why we do that. Then we have parent class C, which is equal to some new parent class. So then we print A, we print B, we print C. So we print A, and when we have the print of A, it's a child class. We're storing it in a parent class pointer, but it doesn't matter because it's a child class, so it's going to output child. B says it's a parent class and cast it to a parent class of A. Oh, that's why. So this is a parent class pointer, and we're saying cast it to a parent class from A. Okay, that's cool. It's a parent class pointer. Doesn't matter because the object underneath it is still a child, so it's going to output child. Lastly, we have parent class C pointer equal to new parent class. This is actually a parent class object, which means when it gets called for its print, it's going to say parent. So why does this happen? I think I posted the midterm solutions for this as well. But basically, when the print of pointer is of A is called, CC classes happens because virtual is always going to look for the most specific version it can find. So because we declare this as virtual, when we call this on the pointer, it's like, okay, find the most specific version that we can find of this particular function. Well, it's a C class itself, so it's going to call the C class version. Can you explain what really happens in static cast? I don't really like having static cast here as opposed to just casting it to a p-class variable. So you could have just said cast p-class. This is going to be the exact same thing. So we're just saying pretend this is a p-class. Sorry, you don't actually say cast. You just cast it like so. So you're saying pretend this is a p-class. So the difference between dynamic and static cast is that static cast is just going to assume that you've done it correctly and that you can cast it that way. Dynamic cast will actually check for you. So if you couldn't cast it that way, then it would throw an error. So what's actually happening here is we're saying we have some parent class B, and we're casting A to be a parent class pointer. So A is a parent class pointer, and we're actually casting it to a parent class pointer. Kind of ridiculous. We should do this instead of class. Kind of ridiculous to do this, but I think the whole point was just to make sure that you understand that it doesn't really matter what happens here because when print is called through B, the print function of B will still call the child class one. Since the object itself is still a child. So remember, if the object itself is what's stored there, so we actually have a child object, so even though we're saying pretend it's a parent class pointer, pretend it's a parent class pointer, the actual memory that was in that is actually going to be the child class. Don't worry about, we went over cast and polymorphism, but don't worry about this question for the midterm. I'm just going over it so that you guys kind of understand it a little bit more, because this is completely cut out. Anything that included the polymorphism lecture slides, I'm not asking on the midterm. 36. No, it never actually converts it, because we're not making a new object here. We're just casting it. The only objects we make are this one and this one. Test class. Okay, so this one's actually not a bad question. Yeah, it will be on the final, but that's okay. Like, it won't be a lot on the final. The final is almost entirely going to be like linked lists, queues, stacks, maybe analysis of algorithms, we can get to it, and templates. Test class, what was I saying? Right, so here we have some test class, some integer pointer p, and it's got some constructor, some int x. Where do you leave this as? Arial? Gosh. Oh, so much better. Don't know why you'd ever have your code listed as Arial on a midterm. uh, No comment on the coffee versus Adderall. Okay, so here's our test class. We have some integer pointer, and the constructor takes some integer x and sets p equal to some new integer, and whatever the x value is passed in, it sets p to be that. So set value takes some integer, changes p to be pointing at whatever that value is, print just prints out whatever that value is, and here's our test classes, or our main method. So test class A and test class B. So test class A is printed 10, test class B is a 20, A is equal to B, so now A is equal to B. These should be the exact same object in memory. So what are we actually getting? So A print, we're going to get 20. B print, we're going to get 20. A.set value to 12. Okay, now print A. Okay, fine. So now A is equal to 12. B.set value 15. Okay, A.print. What are we going to get? Well, we're going to get 15, and then we're going to get 15. So why are we getting this? So the output of print depends on the variable, the value that's passed in here, and we're storing that into the pointer. So when we first assign B to A, we're just saying, okay, simple assignment is done, and we get shallow copy. So we didn't make an explicit copy constructor in this case. So it actually copies the pointer itself. So now both A and B have this specific P pointer. So if we change this, it changes both of them. And this is like kind of when we talked about why you make your own explicit copy constructors, because most times this is not what you want. You actually wanted this one to be printing out 12 still, and this one to be printing out 15. But if you didn't put your own copy constructor here, then this gets copied directly. So this integer pointer just gets copied because it's member-wise assignment. So it says, okay, your pointer p is now equal to this other guy's pointer p. So now they're the same pointer. That doesn't make a separate pointer to some other memory. It just says, or sorry, your pointer is now pointing at the same place. So like you won't end up with a situation where you can change one without changing the other, because you actually end up with the exact same pointer. Okay, moving on to 37. Operator overloading. So this question is about operator overloading for a complex number. Okay, cool. Some complex number class, double, real, imaginary, public, complex, double x, double y, real equals x, imaginary equals y. Sure. C out real plus imaginary I. That's cool. Missing member functions that you need to define. Okay, well, we know we're going to have to do something there. Int main. Oh, what would a copy constructor look like? It looks like, oh gosh. Looks like this. That's a copy constructor. There's also in the midterm, I think, somewhere else. Way up here. Okay. What the heck? Maybe I'm crazy. Maybe there wasn't it previously being called in here. But that's what a copy constructor looks like. And remember, a move constructor is just, it has two of these. Whoops. That was the whole thing. And that section about where the... Oh, it was in here? Question 7. No, that says, oh, this question 8 is not automatically called when. That's talking about a copying constructor, but doesn't actually show it. Where was I? So where do we, in the notes, if you're looking for the copying constructor, it's actually in, I think it's in this one. So 5, more classes extended. Friends, default constructor, blah, 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 copy constructor. Yeah, right here. So this is a copy constructor, and this is where it is in the notes. It's going to be in Unit 5, more classes extended. And then remember a move constructor. Oh, I talk about it in this one too. Yeah, L values, R values. A move constructor just looks like this. So this is a move constructor. Notice it's not const, and it's 2 references. It's a reference, whereas a copy constructor is just a single reference. All right. Okay, so here's our complex class thing. So give a complete definition of the missing function to overload the plus operator for a type complex. All that in complex arithmetic, a plus bi plus c plus di is equal to a plus c plus b plus di. I don't really like this question. I'm pretty sure I switched it with something else, but let's do it anyways. So you're going to have complex. Okay, well, I'm going to type the code here. But it's probably going to try and like capitalize stuff. So we have the plus operator, and it's going to take some reference to a, or I don't know, whatever we want to call this, other. Let's call it other. I like that. And then we're going to say we need to make some new one, so we make some new complex z. So we make some new complex number, and we say, okay, when we're going to return this z, we need to add the 2 real portions and the 2 imaginary portions together. So we say z.real is equal to a.real plus this dot real. Oh, no dot. And then we're going to say z dot, what do we call it, imag? Imag is equal to a dot imag plus this imag. And then we just return z. So now when this comes back, it's going to return some new complex number that we made inside of here, inside of our plus operator. We just added the real portions together, we added the imaginary portions together, and when it returns, we'll actually get some new complex number that was the previous complex numbers that we called this on added together. What is the output of the program after the missing function is added? Okay, 1, 2, 4, 5. Z1 plus Z2. Is it real and then, yeah, real and then imaginary? So this is going to be 5.0 plus 7.0i. So I'm assuming it's going to be 5.0 plus 7.0i. Actually, let me open this up. Oh, yeah, okay, that's what it is. So the output for this is going to be 5 plus 0, 5.0 plus 7.0i. Because remember the print function that we're calling this z.print, it just adds this little I after the imaginary portion. Would it be okay / better to do it by adding the a's real and imaginary parts? Yeah, of course, but you still need to return a new object. Because otherwise you're changing the other objects. Yeah, doing it without this is totally okay. It just sucks because, like, he didn't use underscores here. So, like, you could have actually just been, like, plus real. Because it's the one that's being called on this. No, I wouldn't use marks if you don't. Well, no, because I think, well, actually, I don't think I used the references in the class notes when I talked about operator overload for plus. No, I didn't. So that's totally okay. You don't have to use reference. I mean, in general, you want to be using reference as much as possible, but I'm not going to take away marks if you forget to do something like that. So this question is completely gone, but it's not particularly difficult. So we'll just do it really quickly. So below is a procedural style data type for point variables. So we have some structure point, has two doubles x, y, double distances, point A, point B, point D is equal to A plus B, double R is equal to something, return R. Okay, seems pretty straightforward. Void main makes a new point London. The distance is equal to distance of Toronto, London, so it just calls this distance function. Double time is equal to distance divided by 100, and we want it to print out 0.5. Okay, so how would we do this in an object-oriented way? So we need to create what this struct was in a class, but do it more object-oriented without just like abusing the fact that everything is public here. So we want to have private. Whoa, why am I typing in red? Red is not cool. So angry. There we go. Okay, private. And we'll just say double x. I don't like that. Double underscore x. But then I got to change. No, it's fine. Double underscore y. Okay, so we have two doubles. We have double underscore x and double underscore y, representing the x and y that previously were in the struct. And we're like, okay, well, we need a constructor for this, so let's make a new constructor. And we'll want point double x is equal to 0 by default, and probably double y is equal to 0. If we want to do it this way, we probably want to just use a member initialization list, but since we didn't cover that a lot, I'm just going to say underscore x is equal to x, and underscore y is equal to y. Should probably put that in a different line. Boom. So now our x is equal to x, and our y is equal to y. We're good to go. We made our constructor. Is there anything else we need to have? Let's see. Well, distance has this minus operator here, so we probably have to have a minus operator somewhere. So we're going to make the minus operator. I'll say something like, I don't know. Point will be good and actually return this. Point, no, operator minus, take some other point, so constant point reference, I don't know, we'll call it B, other. Sure. Did I close that one? Okay, I did. So point do I want to make this on the heap? What did he use on his? Made his in the heap? Why? Whatever. Point B. So saying B dot I can't say that. But I don't have an easy way to access these. I really don't want to do this. Turn. Okay, disregard all the extra capitals that are popping up right now. That kind of sucks. What was I doing? Yeah, so B dot. I can just call it all at once. So our x's. So our x's are just obviously going to be the two x's that we had minus each other. So this. Now let's say underscore x minus other dot get x, and underscore y minus other dot get y. So there's our point B, and then we can just return B. So now we just return b. That's our minus operator. That should be fine. It's starting to look really gross. Okay. Distance is called from here, Toronto, London. Does he want us to change it? Whatever, I'll just make my own distance. Whoa, not double. 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 Okay, pretend that's not capitalized. Distance. Point. A. And, yeah, this one won't be on the midterm. Not this particular kind. I'll ask you to do something similar, like make your own class, but it won't be like converting a struct to something else. This shouldn't be in here. So we make some new point, so say, I don't know, call it D is equal to A minus B. So now we've correctly done that, so that's okay. And we say double R is equal to square root of square root, right? That's how we do it. So yeah, D dot get X times D dot get X and plus D dot get Y times D dot get Y. Hopefully I close those brackets correctly. Turn R. And so this is how you would do it in an object-oriented way. You notice it's a lot more actual code. Oh, that doesn't need to be there. And it also looks really gross when I type it out on the Word file here. But it does become a lot more extensible. So structs are good for piles of data, which is fine, but otherwise you probably want to use objects as much as possible. Okay. Oh, fine. I guess he gave you a ton of room to write that out. Use a define copy constructor. Okay, this isn't too bad. So here we have some class, circle, and we have public int get radius, circle, takes a copy constructor, and it has a private integer pointer. Then we define the member functions outside, so we define the constructor. So normal constructor is printed out, pointer equals new int, and the pointer is equal to len, so whatever you pass in here is the length. Our destructor is just delete the pointer, so we don't have memory leaks. We have int circle get radius return pointer. Okay, so it just returns whatever the pointer is. So complete the definition of the copy constructor. Didn't give us one. Oh, it started here. Use the following incomplete skeleton below. So here's our copy constructor to start with. Notice the parameter list is empty. Well, he kind of gave it away up here. So we just want const circle. Assuming I can type correctly, circle. Oh, I think my brother's supposed to be coming. Turn that up. So we have const circle, I don't know, whatever, other or object, I think is usually what you want it. So that's going to be the parameter list for our copy constructor. We can leave the copy constructor used in here. Copy constructor code goes below. Okay, well my copy constructor code is just going to be pointer is equal to new int, so that we're not copying the pointer directly, because otherwise why are we making our own? And then we're just saying whatever our previously pointer was pointing at, we're going to set it equal to OBJ's pointer. Actually, this probably has to be surrounded like this. There we go. So now we have some new pointer that's set there, and this is going to be our copy constructor. So that's the 4 marks. So you probably get 1 mark for having this, 1 mark for having this, and 2 marks for having the same one that you have here. So you know it's const circle this because that's how he declared it up here. So that one's actually really easy. It's just cluing in that the prototype was already declared, so when you have to write it, you just have to copy what the prototype was asking for. So assume we have the following main function and a display function in your program. So write the output. Oh, displays in quotes. Write the output of the following program. Recall all the places when a copy instructor is automatically used. Okay, so display circle obj. All right. Cout radius of circle obj dot get radius end line. Main function of the program. Circle circle 110. So this is going to be a normal constructor. So that'll print out normal constructor. So actually we should print out what this is going to print out. So we already know the first one is going to print out normal constructor. Circle 2 is equal to circle 1. So that's going to call the copy constructor because we're just saying this is identical to also saying this. So that's what a copy constructor is using because we're making a new object from the values of a previous object. So now we'll put out copy constructor used. Display circle 1. Notice that our display does not have a reference here. It does not have a reference. Therefore, we're passing it by value. So when we pass something by value, we're actually going to end up calling our copy constructor. So then you will say copy constructor used. Again, so twice in a row. Once for this line, and once for initially passing the circle to display. Then it will say radius of circle is equal to 10. Oops, doesn't need to be like a line like that. What is it? Actually, it's radius of circle, and this is a colon. Then we're going to call display circle 2. So that means the copy constructor is going to be called again. So copy constructor used. And then it'll put out radius of circle 10. So again, this is going to call our normal constructor. We're making it from just an integer. Then this is going to call our copy constructor because we're making it from another circle object. This is going to call our copy constructor, and then it's going to print out the radius of the circle. And this one's going to call our copy constructor, and then it's going to print out the radius of circle. Okay, last question. Considering the following UML class diagram. So there's a question very similar to this that I think I mentioned that I had on our midterm. So instead of just being, consider the following UML class diagram, write the definitions for it. You can just write prototypes or something like this. I believe what I do is I write this situation out in English or something similar to this situation out in English, and then I say this UML diagram may help you. So the UML diagram will be identical to how I wrote it in English in point form, and you're just asked to, why is the second radius 10? Because the only one so this is 10, then we take circle 2, and we copy circle 1. So circle 2 is exactly the same as circle 1. Like, their internal pointers are going to be both pointing to a 10. So circle 1 is 10, and circle 2 is 10. That's the whole point of using copy constructor, right? We didn't pass any other numbers, so circle 2 is going to have the same member variable values that circle 1 has. Okay, so how would we make these three things? Alright, so we need 3 classes. We can tell 1, 2, 3. So let's start with bank account. So class, you know what? Hopefully you guys have the midterm open on yours as well, actually. Oh, nice. Beauty. Class, bank account. What do I want to save this? Desktop. Something.cpp. Why did you use the reference operator? That way it actually returns a reference to it. Otherwise it's going to call the copy constructor each time. So you actually want to be passing the reference as often as possible in all of your operator overloads. Otherwise you're actually going to be creating a copy of that object as opposed to passing that object directly itself. What was I doing? Okay, so we have to make 3 things here. So we have to make class bank account. Sure. And we know that it's going to have, so minus means it's private, so let's start with that. Private, and we'll have string owner. So it has some string called owner. What else does it have? It has another private one. This is double, with double, oh my gosh, double balance. Okay, now it's got some other things. So it's got a plus sign, and a plus means that it's public. So it's going to have public. It returns a boolean, so we'll say boolean deposit double, I don't know, amount. That's what they have there. We don't need to put anything else. We just need to know that it exists. You can just use a prototype for that. What else does it have that's public? It has withdraw, so we say boolean withdraw double amount. Okay. Does it have anything that's protected? Yes, it does. So protected, we have get name, which returns a string. So string get name. And we have get balance, which returns double. So double get balance. Oops. So that's all we need for a bank account. That's all you need to put down. You don't need to actually implement these things themselves. You just need to have the prototypes for them. Okay, so the next one. We have money market account or CD account. So let's go with money market account. So class money market account. And so we are saying, okay, well, we know that it inherits. So we'll say public inheritance from bank account. What does this have that bank account didn't? It has private int num withdraws. And then we have public. It has its own version of deposit, so bool deposit, if I can spell it correctly, double amount, and bool withdraw double amount. Is there anything else we need for that? Nope, that's it. Money market account only needs private number withdraws and deposit and withdraw as its two public functions. So finally we have one last class, which is going to be class CD account. And that's going to inherit from bank account. Oops. Too many of the things I have open. There we go. So what does it have? It has some private interest rate, which is a double, so interest rate. How did you know it was public bank account? It does. This actually, like this inheritance triangle here, means public. When I write in English, if I don't specify the type of inheritance, I don't really care. So you can make it either public or private or protected if you really want to, but you should really just stick to public or private inheritance. But either I would accept either for just this. You could just say bank account like this, or you could say private. Heck, you could even say protected if you really wanted to. But public is just the ones that, the version that I will by default use when I'm making classes in C++. So we have some public. So we know that this is plus here. So we just say, okay, well, these are the exact same thing. So I'm going to be super lazy and just actually, no, I'll type it in. Bool deposit double amount. And finally, bool withdraw double amount. That's it. That's all you would need to answer this question. So this question was only worth 5 marks. Yeah, there's no way. If I was giving you guys this question, this thing would be worth like 10. I'm pretty sure what I've changed this one to is very similar, and I made it worth 10. So you would gain like a bunch of marks for having the bank account correctly. Probably like close to 4 marks for having the bank account, 3 marks for having the money market, and 3 marks for having the CD account. So you're going to have marks for having the private, public, and protected, like correctly, like from what I've said in the English version or from what you can read from the UML diagram. You're going to have the inheritance, so that'll be a big one for getting the marks for the money market account. And then do you have the proper, do you have both of the member functions here for each of them, and do you have the private variables that they also had? Yes, there's something incredibly similar to this. The difference is going to be, I'm going to say it in point form. So I'll be like bank account is a class. It has bank account, has two private variables, owner and balance. Sorry, string owner, double balance. So it'll actually be typed out like that. And that is it. Okay, is there any other questions? Plus is private. No, plus is public. So plus is public. Octothorpe hashtag, pound symbol, whatever you want to call that, is protected, and minus is private.